In this video, we will study the last problem of the internal flow between two parallel paths of the mixing between the Couette flow and the Poiseuille flow. Okay, and in this model, we will a little bit modify the setup of the Poiseuille flow by changing top of the top wall from the fixed wall to the moving wall, which the upper velocity is equal to 2 meter per second in the light in the, of the flow direction from the left from the light to the left hand side. Okay. In this case, we can modify, right? We can modify the setup of the Poiseuille flow. Okay. Go to the SCTP in the P processor. Okay, and then drag and drop the mesh of the parallel page. This file, exercise 1 parallel page. Drag and drop. And then we will a little bit modify of the setup condition of the Poiseuille flow. In this case, the S file of the Poiseuille flow. Drag and drop. Okay. And then go to the unrestricted condition and change the boundary condition. Okay, and inlet is the velocity inlet, outlet is outlet. Okay, okay, maybe the outlet is maybe the outlets we should to change from the picture outlet to the natural inflow or outflow. Okay, I will cancel the outlet condition, and the top wall I will set up the top wall. We will set the moving top wall. Moving top wall. Okay, and define the moving velocity of the top wall by click the moving wall and set the transition velocity of the x in x direction. In this case, define -2. Okay, and click. Okay, and return to the boundary of the outlet. We should change to the natural outflow or inflow. Okay, we change the setup and the file name. Okay, I will change the output file for the exercise 3, the Poiseuille flow. The clue is for Poiseuille flow. Okay, and I will save this file and edit the graphics file. Okay, now we finish the setup and then click save and finish. Save the S file by using the name as exercise 3 Couette and Poiseuille flow and click save. Okay, now we can change the inlet view with inlet velocity. Okay, and outflow for the outlets, natural inflow and outflow, and moving wall. Okay, in this case, I have a mistake. In this case, define the top is the top and the bottom wall is the moving wall. Okay, sorry. We should to boundary condition. Okay, for the bottom wall, I will cancel. Now the top wall is the moving wall. The bottom wall I will define for the wall condition, and then define this wall by using the name of fixed wall. Okay, and unclick the free sleep wall and define the stationary wall, and the wall type is smooth surface. Click OK and click save it again and save in the quiz flow and Poisson flow. Okay, now you can see the boundary condition, the inlet, right? Inlet is the velocity inlet, the outlet is the inflow and outflow. The top surface is the moving wall and define the moving velocity in the negative x magnitude is 2 meters per second. Okay, and the bottom wall is stationary wall. Okay, now it's symmetry of both sides. Okay, analysis and click save file again. Okay, now we finish in the process of setup, right? By a little bit changing of from the previous problem of simulation for the Poisson flow, and we use a little bit change to define the top is the moving wall and the outlet is defined as the inflow and outflow. Okay, finish in the step of the pre-processing. Okay, now I will exit from this the window of pre-processing. File exit. Do you want to save? No, not save. Exit. Okay. The next step, equation exercise number 3 of the Couette flow and Poisson flow. We will go to the solver. Okay, double click on the solver. Then drag and drop the exercise 3 of the Couette flow and Poisson flow equals yes. Stop. Set up the horizontal axis. Okay. Now the calculation is finished. Our calculation is finished, right? We can see the residual of the U, V, W, and pressure. We can check the value, right? All of them is lower than 10 minus 10 power minus 5. Okay, now we finish the step of the calculation, and the next step we will go to the post processing. Double click on the SCT clicker, click for the post processor. Okay, and then drag and drop the FLD file of the exercise 3 of Couette and Poisson flow. Okay, this is our domain. I will check, I will set up about the plane 1, right? Perpendicular to the set direction. And I will set up about the mesh, the boundary of the mesh. Set the Y and the thickness is 2, and click on the middle point. Okay, in this case for the supply, and click on off the supply. Okay, now we can see the domain of the pane 1. Okay, and the next step we will plot the velocity profile on this of this flow. Okay, go to the vector plot and display vector. The variable is the velocity, and we will define the location for the uniform. Okay, in the space y, in space v, the meaning of this one is y direction. I will set up for 0.1. Okay, now you can see the velocity distribution of between, this is the Poiseuille flow and this is the Couette flow. Okay, and we will set about 4.2 and the node of 4.5, 4.45, and I will set about the length of this one, the length and thickness, and the arrow 4.25. The size is 4.5. I will change the length of the vector, reduce the scale 0.2. Okay, now you can see the angle 4.5, side 4.75. Side is 1. Okay, now you can see the velocity profile, right, of this the flow simulation. You can see this is due to the moving wall, the top moving wall. This is the Couette flow, and this is due to the pressure level of the Poiseuille flow. Okay, one you can see this is the velocity distribution or velocity profile. Okay, now we can finish the really simple or the first group of example, right, of the internal flow. In the case of the internal simulation, how to say, about the CFD simulation for internal flow of flow between the two parallel plates of 3 condition of the Couette flow, Poiseuille flow, and a mix between the Poiseuille flow and the Couette. Okay, in the step of that is the step of the pre-processing, and in the step of the post-processing, we show velocity vector, and we show the velocity profile of the flow, and we show the pressure contour. Okay, this is the basics. Really, this is the basics problem of the first proof of the internal flow. And the next proof of the simulation, we will go to the external flow of the two cases. The first one, the flow over the aerofoil, and we will simulate by using the steady simulation. And the second of the external flow is a flow over a circular cylinder. When the circular is fixed, and we can see the Kalman vortex strip will appear behind the the buff body, okay, and we visualize the Kalman vortex state, and the phenomena of this flow is unsteady, okay, and we will set up about the unsteady simulation in this problem. Okay, thank you very much for your attention of the first group of this exercise of flow simulation of flow between the two parallel plates. Okay, thank you and see you again to the next video.